Today I am going to present on the topic semiconductor diode, how diode work as a rectifier and the resistance of diode. So, semiconductor diode. So basically semiconductor diode is an electrical one-way gate. We see it as electrical one-way gate because it allows current in one direction and it blocks current in other direction. So we call semiconductor also as crystal diode, which is basically the same. A PN junction is called as semiconductor or crystal diode. As we know, PN junction is a P-type and N-type diode. So we can call basically crystal diode as PN junction diode. So how we represent a semiconductor diode using a symbol? For that we use an arrowhead and a bar like this. So the arrowhead, this portion shows the easy flow of current. Where, as I said, what is a semiconductor? As it allows current in one direction. So that easy flow is represented by this arrowhead. And this bar represents the direction of current which blocks the current. So bar represents where current blocks. Current is blocked. So now we has explained what is forward biased and reverse biased. I will say just in a simple way. Forward biased and reverse biased. So when we can say that a diode is forward biased, when the positive terminal of the circuit is connected to the arrowhead, we will have a positive sign of the arrowhead and negative sign on the bar respectively. So if it is in this way, that is arrowhead represents a positive sign and bar represents the negative side, we can say that it is forward biased. And if the negative terminal of the circuit is connected to the arrowhead side, we will have a negative side on the arrowhead and positive side on the bar respectively. In this case, you can say that this is reverse biased. So, how can we identify forward bias and reverse bias in real life? Because in real diode, it doesn't show in single way. We see the diode way. So, for that, we have two methods. So, the first method is the symbol will be imprinted on that itself. For example, we can take the example of a diode BY127. As I said, the symbol will be imprinted inside the diode itself. So we can easily identify that this is the positive side and this is the negative side. Right? So the first method is symbol will be imprinted on it, and the second method is color using color method. That means we can take an example of diode OA80. In that, two dots will be the color dots, where one will be representing blue and other will be representing red. This blue indicates the base portion, then the bar portion, the line portion is here, and the red represents the arrowhead. So we can identify the terminals of the diode. So we learned the symbol identification. So now we are moving to how diode works as a rectifier. So basically, what is a rectification? converting AC to DC. So I will explain this using a experiment. So we have a voltage input like this, and we have a circuit of an AC supply, a diode, and a load resistor. This is I. So voltage input. So if you are applying a voltage input in the circuit, we will get an output like this. I will explain. Like during the positive half cycle, we can say that we have told already that if the positive terminal is connected to the arrowhead, we will get a positive signal. So during the positive half cycle, the arrowhead will get a positive sign and this will be negative sign. So during the positive half cycle, it is forward biased. In forward biased, what will happen? Current is allowed to pass through it and in this direction, and it opposes in this direction. So we will get an output like this during the positive half cycle. In the negative half cycle, the negative terminal is connected to the arrowhead where it blocks the current to flow through it. So we won't get an output like this. And in next also the positive half cycle, we will get here a positive sign and we will get an output like this. So basically what happens is that during the positive half cycle, the current is allowed, and in the negative half cycle, the current is cut off here. So that's how the rectification works. So now I will give 2-3 problems. You have to identify where it takes place, the forward bias and reverse bias. In which case.
Explain what is in the rectification.
Rectification means we will convert AC to DC. So the input AC is converted to output DC. So I will give a circuit. You have to identify where it is the forward biased and where it is negative biased, reverse biased. So I will explain the first one. Like we can see that the positive terminal is connecting to the arrowhead. So we can D1 and D2, diode 1 and diode 2. In diode 1, the arrowhead is getting the positive side, so we can say this as forward biased. So D1 represents the forward biased, and again the positive terminal here, it is going to the negative side. So the positive sign is going to the bar side. So we can say it as reverse biased. So likewise, I will give you 2 more questions. You have to identify. So this is the voltage input we are giving. In this, we have 2 cycles, positive half cycle and negative half cycle. Anyone have a guess what happens in the positive half cycle? Should I explain? Okay. During the positive half cycle, the arrow gets the positive side and bar gets the negative side. That means in the first half cycle, it is forward bias, and in the second half cycle, the negative terminal gets the positive side and okay, arrow gets the negative side and bar gets the positive side. As we said, this is a reversed condition. So this is reverse bias. There are two more questions. I will give it as homework. So okay. Now we will move to how we will check the resistance of the semiconductor diode. So here the resistance is not constant for a semiconductor diode. It changes based on the bias. So we know that for resistor there will be a constant resistance. But in case of semiconductor diode, the resistance depends on the bias. So we can classify the resistance into two types for semiconductor. The first one is forward resistance and the second one is reverse resistance. So in forward resistance itself, the resistance is not same for AC and DC. So we can again classify it as AC resistance and DC resistance. So forward resistance means it is the resistance offered when it is forward bias. So AC resistance means it is the resistance offered when it is in AC. So to find the AC resistance, we have an equation. Like we represent it as R is equal to the DC voltage across the diode by DC current flowing through it. So this is the equation to find AC resistance. If you are explaining this using a VI graph and considering this as an operating point, this is the respective current here. This is the voltage. So to find RF, we can say that RF is equal to DC voltage across the diode, which we can take as OV. We can represent this by A and B. So OA by DC current flowing through, right? So OB. So in DC resistance, it is the resistance offered by the diode when it is a DC circuit. So to find that, there is an equation. It is the change in voltage across the diode by the corresponding change in current. So to explain this using a graph, we have to take an operating point P and two other points near to the operating point, and the corresponding voltage and current is here. So we can represent this is A, B, C and D, E, F. So for this we will get an equation like this. Change in voltage means you can take OA to OC. OC minus OA by OF minus OD. So this is the DC resistance we get. Now we will move to the second type of resistance, that is reverse resistance. So in reverse resistance, this will be the resistance when it is reverse biased. So if you are taking an example of germanium diode and looking into its ratio to the reverse resistance and forward resistance, we will get it in a way that 4000 is to 1. This shows that how much the reverse resistance is greater, because in reverse resistance there will be no current flow. So the resistance will get infinite. So very high resistance will be here. And if you are taking another case, we will take another example of silicon diode. Silicon diode. We are taking the ratio of reverse resistance to the forward resistance. We will get it as 1 lakh to 1. So it is that much high. The resistance is that much high. So we can conclude by saying that the forward resistance will be very small. It will be ranging from 1 ohm to 25 ohms. The reverse resistance will be at a high rate. Just you can see the ratio, right? So concluding by saying that diode acts as a rectifier by allowing the current in the first half cycle and by blocking the current in the other direction, and the resistance offered will be very small for the forward resistance and very high for the reverse resistance. So because of these reasons, we can see that crystal diodes are widely used in rectifying circuits. So we have altogether discussed what is a semiconductor diode and crystal diode, and forward biasing and reverse biasing, and how we represent using a symbol, how the identification goes, and how crystal diode acts as a rectifier, and then the resistance of the diode. Thank you.